Malaysia is one of the countries that carries out fishing activity to generate the economy and national income. This fishing sector can be divided into two activities, which is traditional and commercial. This traditional activity is carried out to meet the needs of oneself and the family by using traditional types of fishing, while commercial activities are activities that are carried out slowly to gain a profit and the modern fishing methods. The fishing sector is important to obtain human resources in daily life. This fisheries product can be found in the Pacific Ocean area, which is rich in fish resources. In this fisheries sector, there are several areas that carry out advantage fishing activities, including Kelantan, Terengganu, and Pahang. These three states area can be said to be states that influence fishing compared to other states. In addition, this area make the fishing sector their regular occupations to obtain a source of food and source of income. With that, the fisheries sector in this state contribute the highest catch compared to other states and also contribute import and export. Malaysian fisheries use a various method to harvest fish. The Malaysian Department of Fisheries insists that this is the case, citing the use of trawls, fishing net, and covey net and other fishing methods. Depending on the state where it is used, this fishing method is also used. For example, they more often use drift net and trawl on the east coast, such as in the states of Kelantan and Terengganu. However, this is different in the state of Pahang and the fish catch. In the states of Pahang, fishermen use anchovy net to catch a fish such as anchovies, mackerel, and sardines. This study was conducted to examine the relationship between anchovy production using anchovy nets in Pahang. This objective is to identify whether the method used in the states can catch a lot of fish or vice versa. In addition to preserve fishing of fish productions in the states of Pahang. This is said because the type of fishing equipment used to catch fish can affect the source of the fish. The researcher was able to overcome this issue that occurred in Pahang, but as a result of the research, particular uses such as limited the size of anchovy catch based on daily news.
My name is NURYN ELMIRA FARHANA binti MOHAMAD HAMZAH. My number matric is S57876. I will present about literature review. For point 2.1, according to an Italian study, the quantity of fish harvested for non-food use is probably going to gradually decline in the near future. This is due in part to the growth in the usage of feed fish for human consumption and the decrease in the catch of food fish, particularly as a result of the stronger quota and control put in place of unrestricted fishing. There are further supply reducing issues such as a restricted capacity for higher catch fishery production and cost pressure from some crucial inputs such as fish meal, fish oil, and other feed. In aquaculture, according to research conducted in Canada, while other studies claim that the low unit value of aquaculture production in Indonesia and the Philippines reflect the significant contribution of aquatic plant or seaweed, which exceed 60% of the total aquaculture production in these countries and is primarily produced as a source of affordable carrion for export. In addition, the elimination of top predator in this kind of fishery will result in a cascade effect, allowing smaller, low-level high-growth species to flourish without being hampered by predators. As a result, those circumstances will significantly boost fish productivity. Next, I will talk about the point of 2.2. Sumailah's chosen approach provides precedence to the trawlers via a weight sum of present value, resulting in an ideal steady-state cost to harvest of 47.6%. Although Sumailah's results still give the trawler a smaller portion of the harvest than they actually receive, they are closer to the actual harvest shares, demonstrating the trawler's group's strong negotiating position. Some studies have examined potential dynamic bioeconomic implication of ocean acidification as an extra stressor on calcifer species using modeling and decision support technique. Here, we have concentrated on the dynamic of pH as the uncertainty sources, in contrast to previous modeling approaches that operationally address uncertainty in the parameters by assigning mean variance or stochasticity to parameter value. The finding from the bioeconomic model, which demonstrated optimal profitability at this fishing intensity, supported the stakeholder agreement for a sustainable mussel fishery. All of these studies demonstrated how technological innovations based on trawl net modification can help rebuild diminished fish stock by reducing fishing mortality among the population's young. Additionally, other research supported the notion that the fishing pressure on this small-bodied, tall-growing species may be sufficiently reduced. Such diverse systems, despite being productive and homogeneous, lack the ability to adapt to shifting external conditions, making them extremely sensitive to change.
Next, I will present about bioeconomic modeling in fisheries management, the chronic overexploitation of fisheries resources, added to increased economic production costs and market competition with seafood imports, result in low economic performance of Mediterranean fishing fleets, which have explained in part the strong reduction of fishing vessels observed. With the ultimate objective of improving the long-term viability of fisheries, taking into account local specificities, the European Union introduced the concept of regionalization and multi-annual plans in 2000. Among the other things, the Western Mediterranean Sea, the multi-annual plan, established an important reduction of fishing effort of 40% over the period 2020 until 2024. The temporal prohibition of trawling between 50 and 100 meter depth in designated areas, as well as promoting the use of more selective fishing geared to reduce fishing mortality. The state overall objective of the Western Mediterranean Multi-Annual Plan is to align the fishing mortality with FMSY for the 5 main fish stock in the area. For the first one is European hake, red mullet, Norway lobster, deep-water rose shrimp, and red shrimp. For each of the 5 target species, the biological parameters, natural mortality, weight, and maturity at age were considered constant and equal to the average of the last 3 data years from 2017 until 2019. The economic parameters were projected as constant for the 2019 until 2030 projection period. The ability of MSE to provide advice to fisheries management depends critically on how well uncertainty is, and in this application we identify uncertainty on the parameterization of the stock recruitment model for the fishery target species as the main source of uncertainty. The bioeconomic model is a fully coupled model consisting of 4 components. These are an empirical submodel describing the relationship between nutrient loading and phytoplankton primary production, and the second one is a process-based ecological submodel describing the dynamic of phytoplankton and blue mussel biomass, and the third one is an agent-based mussel fishing submodel that allows the fishermen to make decisions regarding fishing effort based on regulations, available mussel biomass, and expected cost and revenue. And the last is an economic submodel for cost-benefit analysis and for simulating the expected profit.
The first section in research method is descriptive statistics, which is a brief description of the sample and data that can describe characteristics of that data. And it has 3 main categories, which is the first one is the frequency distribution. Frequency distribution is the most popular way to describe a single variable. And there are 2 ways to represent frequency distribution. The first one is table or a graph. And the second one is central tendency. The second one is central tendency, which is an estimation of a center at the distribution of the value. And it has mean, median, and mode are the 3 main characters in the central tendency. And the third and last one is dispersion. The spread of the data around the central tendency is called dispersion. It has 2 ways, which is range and standard deviation, which is often used metrics in the dispersion.
Next, we used regression method. Regression analysis is a set of statistical methods for estimating relationship between one or more independent variables and a dependent variable. It can be used to analyze the strength of the link between variables and to forecast their future relationship. There are various types of regression analysis, including linear, multiple linear, and non-linear. Simple linear and multiple linear models are the most frequent. Non-linear regression analysis is commonly used for more complicated data sets in which the dependent and independent variables show a non-linear relationship. Simple linear regression is used to estimate the relationship between 2 quantitative variables, to test how strong the relationship is between 2 variables and the value of the dependent variable at a certain value of the independent variable. Moreover, multiple regression analysis allows the researchers to assess the strength of the relationship between an outcome, the dependent variable, and several predictor variables, as well as the importance of each of the predictors to the relationship, often with the effect of other predictors statistically eliminated.
The third section in the research methodology is econometric, which has totally 7 steps. The first one is statement of theory or hypothesis. There are 2 types of hypothesis which has been used, which is null hypothesis and alternative hypothesis. The second one is specification of the mathematical model of the theory. And the third one is specification of statistical or econometrical model. And the fourth one is data collection. The data in this particular research used are from Department of Fisheries of Malaysia, which is a secondary data from year 2001 to 2021. And the fifth step is estimation of parameters of the econometric model, which is regression. It is a primary instrument utilized to gather the estimates. And the sixth one is hypothesis theory, which is a procedure of examining a claim in order to accept or reject its hypothesis. And the final one is forecasting and prediction. It is a process of forecasting entails by creating prediction based on historical or even current data for the future.
Next is the Fisheries Model. The Fishery Development Model FDM provides a framework for comprehensively examining fishery system as well as a technique for organization to properly understand the system, discover opportunities, develop and test the strategy and scale beneficial interventions.
Hello, my name is ALISA binti Muhammad RADZI and I will continue the presentation for the chapter 3, which is results and discussion. There are 4 simple steps for this chapter. First step is data collection. In this study, researcher collected the data through one source, which is secondary data. The data was collected from Department of Fisheries Malaysia for landings of marine fish by state and species, and number of licensed fishing vessels by Fishing Gear Group and State from 2001 until 2021 for anchovy per scenes in Pahang. Secondly, regression analysis. This second step is to explain variability independent variable by means of one or more independent or control variables. In this study, the dependent variable is number of licensed fishing vessels by Fishing Gear Group and State, while the independent variable is landing of marine fish by states and species. Then, after collecting the data, researcher inserts all the data into the Microsoft Excel to make a simple regression analysis. To run the regression, researcher arranges the data in columns. Click on the data menu and then choose the data analysis tab. You will now see a window listing the various statistical tests that Excel can perform. Scroll down to find the regression option and click OK. Now, input the cells containing the data. In the menu box, researcher click in the input Y range box and then use the cursor to select the column containing the data for the dependent variable. As researchers select the cells in spreadsheet, the range should also appear in the menu box window. Repeat the process for input X range, which is for independent variable data. When everything looks good, click OK, and now researcher can see the results of the statistical test. Another 2 more steps, which is calculation of reference points for maximum sustainable yield as MSY, economic sustainable yield ESY, and open access OA will be continued by other group members. That's all from me. Thank you.
Okay, I will continue my group presentation with the results and discussion that have been obtained from the study. This equation refers to the fisheries model using the form of a regression equation. Cash refer to the dependent variable and anchovy present V and V2 are the independent variables. In this equation, cash equal to 8104.106 minus 2413471 V plus 189.830 for V2. Based on the result of the regression analysis in table 1, it was found that the coefficient value for anchovy present V in Pahang is negative 2413.4712. It shows that negative relationship with the total catch of anchovies. The result show a significant relationship at 1% because it recorded a probability value less than 0.01. This situation means that when there is an increase of 1% in the number of anchovy present used, the total catch of anchovy in Pahang decreased by negative 2413.4712. Next, the coefficient value for the number of anchovy present V2 is positive relationship with the total catch of anchovies in Pahang, which is 1
189.8303. This result shows a significant relationship at 1% because it recorded a probability less than 0.01. This point shows that when fishermen in Pahang increased the use of anchovy praseed by 1%, the catch of anchovies increased by 189.8303. This is from me. Thank you.
Hi, my name is SIVAKUMAR. My metric number is S60569. Today I will explain Table 2. Table 2 shows the maximum sustainable yield MSY, economic sustainable yield ESY, open access economy ESY, and maximum carrying capacity NCC, which are used to show the catch of anchovy in Pahang using anchovy praseed. The result of the study found that MSY recorded a total catch of anchovy is 50,172, which is equal to 15 vessels using anchovy praseed. The anchovy catch obtained from 50 vessels using anchovy praseed was RM88.462 billion per metric ton. Indirectly, the results obtained by fishermen from the anchovy catch above recorded a profit of 592 billion ringgit. Therefore, MSY showed the catch and profit reached the maximum level obtained from fishermen using anchovy in Pahang. On the other hand, this study found that ESY recorded 50,170 or equal to 15 used of number of vessels using anchovy praseed. The catch obtained from 15 vessels using anchovy praseed is 1,101.162 per metric ton. Indirectly, this profit obtained from the total catch as much as 7,540,350.4. It is said that at ESY level, fisher get more profit from the maximum profit available at MSY.
Study found that in the open access economy, as known as OPE situation, the number of anchovy praseed in Pahang is seen to be increasing, which shows the use of anchovy praseed by 30 vessels. This is because at that stage, there was no control carried out by the Malaysian Fisheries Development Authority, known as LKIM, to impose any restrictions on fishing activity. This situation encourages more fishermen to go out to carry out fishing activities in the sea. After doing calculation, marginal sustainable yield is achieved at 88,496 cash and 15 of effort.
In conclusion, the result of investigation show that there is a positive and negative link between anchovy nets and the amount of anchovy captured in Pahang. The coefficient value for anchovy net in Pahang indicate a negative link with the total anchovy catch in Pahang, which record a value of negative 2,413.4712. These circumstances demonstrate that when the quantity of anchovy net employed increased by 1%, the overall catch of anchovies in Pahang reduced by 2,413.4712%, while the second result indicates the coefficient value for the number of anchovy net used when doubles, demonstrate a positive association, which is 189.8303. This demonstrated that increasing the usage of anchovy net by 1% improved the capture of anchovies by 189.8303%. Following the examination of the maximum sustainable yield, MSY approach revealed that the harvest from 15 fishing boats under licensed anchovy net in Pahang achieved the highest profit of 519,789,457, while the economic sustainable yield ESY is more profitable than the MSY, totaling 7,514,315.4. In the state of open access economy (OPE), the usage of anchovy trawler in Pahang increased from 15 to 30 vessels, where there is no regulation by the Malaysian Fisheries Board. The consequence of this rise may result in uncontrolled overfishing and a decline in the future source or stock of fish. As a result, the government must play a role in enforcing limitation and entrenching community control over fishing in order to maintain the sustainability of fishing resources in the future. Thank you.